Okay, so today we're talking about trigonometric values for special right triangles. So the two special right triangles we're talking about specifically are 30, 60, 90 triangles and 45, 45, 90 triangles. So up here on the left side, we have some values here, like a 2, a root 3, and a 1. Those are all found using some mathematical methods. It's not really important for us where they came from for now. We just need to accept that these are the numbers. So we don't need to memorize these. We just need to have them written down somewhere so that way we can use them. And the way we're going to look at them today is we're going to look at trig functions specifically. So for example, if I look at sine of 30 degrees, I think about 30 degrees here, and I say sine is going to be the opposite over the hypotenuse of the triangle. So sine of 30 degrees would be 1 over 2. And I'm going to fill in this entire table like that and say, okay, now if I want to do sine of 45 degrees, I could just pick this one. I just get 1 over square root of 2. And then finally, if I do sine of 60 degrees, I get square root of 3 over 2. The only thing that gets a little tricky here for these three equations is that I don't want to have a radical in the denominator of a function. So when I do sine of 45 degrees, and I get 1 over square root 2, I want to get rid of that square root 2 in my denominator of my function. And the way I do that is I multiply by that radical as a 1, so root 2 over root 2. And what happens through our multiplication, which we just did in mod 4 with radical functions, we get 1 times root 2 is root 2, root 2 times root 2 is root 4, and square root of 4 is 2. So that's the idea to take care of this middle value here. We'd write that as square root 2 over square root 2. All right. For cosine functions, I can do some very similar things. I'll say cosine of 30 degrees is going to be adjacent over hypotenuse, so root 3 over 2. All right. Cosine of 45 degrees is adjacent over hypotenuse, so it becomes 1 over root 2. And we just proved that it's also going to be that root 2 over 2. And then finally, cosine of 60 degrees is going to be 1/2. The last three trig values we have is tangent. Tangent of 30 degrees, that's going to be opposite over adjacent, so 1 over square root 3. And unfortunately, we have another radical in the denominator here. So if we multiplied by root 3 over root 3, we'd actually get square root of 3 over 3 for that tangent function. All right, we don't need to find these values again. We just need to have this table handy for us. So that way, if I ever ask you on an assessment or something, hey, what's tangent of 30 degrees? You could say, hey, that's root 3 over 3. I have that table easily available for myself in my notes. All right, so keep these notes handy. Tangent of 45 degrees is going to be 1 over 1, so that just becomes a 1. And then finally, tangent of 60 degrees is going to be root 3 over 1. So we can just write that as square root of 3. Okay. To use this knowledge, these are the general rule of thumbs that we'd use for any trig function. If I asked you to find the exact value of a function, first of all, the word exact means that I want no decimals. So very important there that we're leaving our answers as radicals only. Okay, radical answers. And I'm trying to solve for x here. I have to think about which trig function is going to represent, to this 30 degrees, is going to represent adjacent over hypotenuse. Well, adjacent over hypotenuse, that's going to be cosine. So I could say cosine of 30 degrees equals x over 8. And then I have to ask myself, looking up at the table, hey, cosine of 30 degrees, that represents square root of 3 over 2. So I can do a substitution method and say, okay, well, root 3 over 2 equals x over 8. And then to get x by itself, I can multiply both sides by 8 And just think about it as like 8 over 1 even. So I get 8 times square root 3 over 2 equals x. And then my final step, if possible, is to try and simplify. 8 divided by 2 is 4. So I get 4 square root 3 equals x. So when I'm looking for this side length here, I'm going to get 4 square root 3 is my x value. Really important to double check and make sure that that 4 root 3 is a shorter side length than 8. Like you just put that in your calculator and you should get some type of decimal. But important to double check that because you don't want you want the hypotenuse to always be the longest side of the triangle. All right, so now I have 3 practice problems here. I want you to find the exact values for x and y. Exact values for x and y. Take a couple minutes to work on that now. I'll put the answers up in just a minute here. Okay, so after you had a few minutes to work on these problems, go ahead and check your answers now. Feel free to pause the video and take a look. Let me know if you have any questions at all. All right, so for the second part of class today, we're going to be talking about solving triangles. So solving triangles means we're going to look for every single angle and every single side of each specific triangle. And when we're solving triangles, we're going to require a graphing or a calculator. It doesn't have to be a graphing calculator, but it has to be a scientific calculator with sine, cosine, and tangent at the very least. And what we want to be able to do is we want to, for these ones, we're not going to be able to do exact answers. We're going to need to round to the nearest hundredth, which is 2 decimal places. The first thing we can do is we can identify information we already have. Whenever we're solving a triangle, we should be given some information. So for example, angle A here, the measure of angle A is 28 degrees. That's given to us. We know angle C is the 90-degree angle. And we know side length B is 15. That's the given information that we started with, was those 3 things. Now, if I'm looking at this triangle and I say I have 2 angles of a triangle, I know a triangle adds up to 180 degrees. So if I said 180 minus 90, I'd get 90. And then if I did 90 minus 28, I'm going to find the third angle, angle B. And that happens to be 62 degrees. Okay, so that's how I can find the third angle right there. Now, next, when I'm looking for missing side length, I can use these trig functions again. And whenever I want to use the trig functions, I want to start with the number that was given to me. I think that's always a good safe bet because if I screw something up on my calculations, if I'm using the number that was given, I have a smaller chance of screwing up the next one. So if I'm looking for side A, and I'm using side B, I'm going to use the tangent function. Tangent of 28 degrees equals A over 15. Now, I want to get A by itself, so I need to multiply both sides by 15. And I get 15 times tangent of 28 degrees equals A. Now what I can do is I can put this into my calculator. It depends on the type of calculator you have, and you'll do tangent of 28, and then you're going to multiply your answer by 15, and you'll get an answer for A that you're going to round to the nearest hundredth. So my answer for A was 7.97564. Nearest hundredth is 2 decimal places, so this is going to be 7.98. All right, because I'm rounding to 2 decimal places, and it was 975, so I have to round up a little bit there. And then finally, looking for the last side, side C, this one looks like it's going to be a cosine function. Cosine of 28 degrees equals 15 over C. Now, I'm going to have to multiply both sides by C, and I get C times cosine of 28 equals 15. And then to get C by itself, I have to divide both sides by cosine of 28 degrees. So I get C equals 15 divided by cosine of 28 degrees. And that's what I'd put into my calculator. And I end up getting C equals approximately 16.988, so 99. rounded to the nearest hundredth. That's how I would solve for one triangle like this. So start with the given information, and then from there you're going to hopefully you can find the third missing angles, and then you can find missing sides using SOHCAHTOA and your trig functions. Okay, so here we've got two practice problems, and there's no triangles drawn. So the first thing you're going to need to do on these types of practice problems is to actually draw the triangle. So for example, I'll draw a triangle here. I know angle B is 45 degrees. I can label it however I want, just as long as it's accurate here, and then I can fill in my measurements here. It's a 45, 90, all right? And then I know side C is 5, and when we talk about sides of triangles, we always want the sides to be opposite of their corresponding angle measures, and they're going to be lowercase letters. So notice side A is opposite of angle A, side B is opposite of angle B, side C is opposite of angle C. Okay, so we fill in the given information, and then it's up to you guys from there to go ahead and find the values for the angles and other side lengths. Because this one is a 45, 45, 90 triangle, whenever you see 45, 45, 90 or 30, 60, 90, that means we want to find exact values, no decimals. Okay, for this particular problem. If it was a 30, 60, 90 triangle, I'd ask you to do the exact same thing. On the second example here, when it says angle A is 71 degrees and side length C is 20, this time we're not going to need to worry about finding exact values because the measure is 71 degrees. We would just do approximate rounded to the nearest hundredth for this example. Okay, so now that I've sketched the triangles, I want you guys to go ahead and practice these problems, and then we'll check our answers in just a minute here. So take some time now to do that. Okay, so we have the solutions posted here. Remember that for number 4, your solutions should be exact value answers. And for number 5, you should have decimal approximation answers. Very important to do that. Double check your work, make sure you're feeling okay with these types of problems, and then go ahead and get started on the assignment.